Good morning, kiddos. Thanks to those of you who watched the first video. Your extra credit has been noted. I want to talk to you today about number 1 and number 6 on page 399 because the way they've represented exponential growth is just slightly different. It really deserves a comment. So this is number 1 here about the clothing store, where we've got an initial value of $175,000 and then a growth rate of 10% each month. And while they give you the function, I want to talk to you about why the 10% is represented as 1.1, because it seems like 10% would maybe you just put a 0.1 in there or a 10%. So let's just look at the way an exponential function works in the calculator. I'm going to go to the table, and here's my function, and I'm going to change the 1.1 to just 1, the number 1. And we're going to look at the table. Start from 0. So if I leave the this value here, the growth rate at just 1, everything's going to stay constant. Nothing's going to change because 1 to the 6th, 7th, 8th, 9th, 10th power is still just 1. So in order to show a 10% growth rate, I need to be 10% above 1, and 10% of 1 is 1/10. So if we go to the table and we change that 1 to a 0.1, now I'm showing a 10% growth rate. I have 10% more than what would keep my function constant. And if you look through the table, now you can see that you start from your initial value, but you grow at a rate of 10% each month. Another important thing to note here, just generally about exponential functions, is the language. As x is increasing, y is also increasing. And we can be even more specific. As x is increasing towards infinity, y is also increasing towards infinity. And then also we can think about increasing towards negative infinity or decreasing towards infinity. As x decreases towards infinity, y is going to decrease also. But y doesn't decrease towards infinity because it's an exponential function. Y is going to decrease toward 0. And that's a little more obvious in other examples. When you start from 175,000, it's sort of difficult to see that you're decreasing towards 0, but I can guarantee you that's what's going to happen. As x decreases towards infinity or increases towards negative infinity, y is going to decrease towards 0. But it's never going to get there because it's asymptotic, or there's an asymptote. And we can see I'm actually going to get maybe kind of close. I'm already at 20, 10, and as x continues to decrease, y is going to get closer and closer and closer to 0. It doesn't matter what my a value was, but it's never going to get there. You're going to see these 4s, 3s, 2s, and this has become a 0. Then the units place is going to count down, or I'm sorry, the hundreds place is going to count down to 0, and then the thousands place is going to count down to 0, and it's going to look like we're getting all the way, but we're really never going to get there. You could keep going back on x, more and more negative, and y is just going to decrease towards 0. So that language is very important. And now we're going to look at number 6, where it's a similar problem, but now we're dealing with exponential decay. And this time our initial value, the value of the car when he buys it, is $25,000. And then it says, as a general rule, the car loses 15% of its value each year. So the decay rate is 15%, but then we need to look at the way that's represented inside the function. The value as a function of time is equal to the starting cost times 0.85 raised to the t power. So again, if our decay rate is 15%, why are we putting 0.85 here in the equation? And again, let's just think about what happens when we leave our function with just a growth rate of 1, or a b value of 1. Well, you look at your table, and just like before, when the growth rate or the value is 1, everything stays constant. We don't have any change when we use 1. So our growth and decay are all relative to the number 1. 15% less than 1, what would have kept our value constant, is 85%. So I'll go back to the table. I'll be sure my initial value is correct, 25,000. And then instead of 0.1, or instead of 1, I'll do 0.85, 15% less than the number 1. And now if you look at your table, you can see that you've got your initial value here of 25,000, and then you're decreasing by 15% as each year passes. And now, as a bonus to those of you guys who are actually taking the time to watch these videos, when it comes to your quiz, which I think I'm going to give on Wednesday, this is page 21, or lesson 21-2, page 322. It's homework you turned in earlier. I think I'm going to put this question on the quiz and just ask you to write out the terms given this recursive formulation, and maybe ask for the 5th or 6th term specifically. And I think I will take from this page, I'll probably just take one of these two problems that I just talked about, either number 1 or number 6, and I'll put that on the quiz also. So there you go. I'll see you in class soon.